Okay, we have this questions called literal equations, right? Usually the question would be like, I'm seeing this one, they're saying express the radius of a sphere in terms of V, right? So in other words, they're saying make R the subject of the formula. On this one, you can see that V is instead the subject of the formula. In other words, they're saying at the end, your answer should be like R equals to, and then something like this, right? Questions like this, they are literally just the same way you solve questions like solve for x. Because you could start with something like, let's say if you have something like 2x, let's say plus 1 equals to 5, right? And then they say solve for x. When they say solve for x, they are simply say do what? At the end, your answer should be like x equals to, you see the similarity. So it's the same thing. In this case, they're just saying right now, make R the subject of the formula. On this one, they're saying X the subject of the formula, right? How would you solve this one? You'd say, if it is positive 1, you subtract negative 1, but on both sides. So you'd have something like 2x plus 1. To get rid of that 1 there, you'd say negative 1. But at your school, they taught you what? What you do on the left hand side, you also do it where? On the right hand side. So you'd say 5 and then also minus 1, right? So that this part can now become 0. So you're now going to have 2x equals to 5, or let's just say 5 minus 1, which is going to give us 4, right? You used a method called what? Additive inverse. It was positive 1. To get rid of the positive 1, we said it's the opposite of positive is what? It's negative. So we subtract that value, which is 1 in this case, right? Remember we said what we do on the left hand side, we also do it on the right hand side. So that's how we were able to remove the 1 from the left hand side, right? We got to here. Now, x now is still being disturbed by what? By the 2. Is 2 times x. Since they are multiplying, to get rid of the 2, which is multiplying, what is the opposite of multiplying? It is dividing, right? So we are going to do what? Divide by 2. We're going to divide by 2, right? Remember, again, what you do on the left hand side, you also do it where? On the right hand side. You're also going to divide by 2. In this way, this 2 can get rid of this 2 because 2 over 2 is still 1, right? So now you have what? Your answer will be in the form of x equals to, and then 4 over 2, you get what? Your answer becomes 2. So in this way, we are able to solve it, right? Here I said you used what? The additive inverse. Here you used what? The multiplicative inverse. Just look up for this word in my other videos and then you'll see what I'm talking about here. So that's how you were able to solve it. The way you do this one is the same way you still do what? This one. Are we together? The only thing here is that I think you might find to be a bit tricky is because of this fraction here, right? Let me just up here to show you what I'm talking about. It means you need to know how to work with your fractions, of which you can check in my other videos, right, on how to work with fractions. For example, here we are saying for us to end up with just equals to, right now it is being disturbed by what? For example, the pi, right? Also being disturbed by what? By the 4 over 3. Also being disturbed by what? By this exponent 3. We need to find a way to get rid of those things, right? Now, where can we start? For example, look at this 4 over 3, right? This 4 over 3, where does it come from? It's 4 over 3. 4 over 3 is the same as writing it as 4 over 1 multiplied by 1 over 3. Because when we multiply fractions, we simply just take this one to multiply by that one, this multiply by that one. That's how we get the 4 over 3, right? Also, so to get rid of this 4, right, we'd have to multiply by 1 over 4. Then the 2 can cancel each other because it's going to be 4 over 4. This would cancel, and then they'll be able to cancel each other. To also cancel the 3 there, we'd have to multiply by 3 over 1 so that the 3 can cancel the other one. So in short, I'm saying if it's 4 over 3, to get rid of the 4 over 3, we can simply just, if it's 4 over 3, we can simply just multiply by 3 over 4. So that this can cancel this can cancel this. Then you get 1. In other words, it's as if like this disappeared. So I'm saying on this one here, if we can say this side, let's multiply by 3 over 4. Remember what we do on the left hand side or on the right hand side, we also have to do it on the other side, right? So and then we multiply here by 3 over 4. Then this would disappear. This would be by this by this. And then on the left hand side, we have what? We have also know that the V can be written as a fraction, right? Remember that any number multiplied by 1 is still that number. And also, any number divided by 1 is still that number or that variable, right? In this case, this V here is over 1. So, like I did here with fractions to say, when we multiply fractions, you just say numerator by numerator, denominator by denominator. So is this one is the same as saying 3 times V. 3 times V is 3V. And then 4 times 1 is just 4, right? So in other words, this part we have this. And then here, remember we got rid of the 4 over 3. So we now just left with pi r to the exponent 3. Are we following so far? Now, what are we supposed to also get rid of? This pi here, right? It is pi multiplied by r cube. So since it's multiplying, we can get rid of it using the what? The multiplicative inverse like we did there. We can simply just do what? Divide both sides by pi. We also, this whole thing, we divide it by pi, right? In this case, this would get rid of this. But now, here's the trick. You have to be able to do this one, right? Let's write it. Remember, division can also be written like this. We have 3v over 4, right? And then divide. Remember, division can also be written like this. Divide by what? By pi. And then like we did here, we said any number divided by 1 is still that number, right? So in other words, we can write this pi as over 1. Then this can be equals to, when you are dividing fractions, you can also change this division into multiplication and then write the denominator as the numerator and the numerator as the denominator, right? In other words, I'm saying this is equal to 3v over 4 multiplied by 1 over pi. And remember I said, how do we multiply our fractions? You simply just say numerator by numerator, denominator by denominator, right? So in this case, you're going to have what? Equals to 3v over 4 pi. Are we together? So I'm saying this part can be written as this part. And now we're going to have 3v over 4 pi equals to r cube. Are we together? Now, this r cube here, this r cube here, we are trying to get rid of that cube, right? If you can check in my other videos whereby I was talking about the roots, I said that if you have something like, let's say, for example, r squared, right? Usually when we were getting rid of the r squared, let's say maybe you have something like r squared, okay, let me just say x squared equals to 9. You would see we do what? We root both sides, and then we would say this is cancelling this, and then our answer would be x equals to plus or minus 3, right? Simply because the 9 there can be written as 3 squared. And then I said we call this the square root because it has a 2 here. And I also mentioned that the square root is equal to what? 1 over 2, right? It means also to get rid of this 3 here, we can instead use the cube root because it will be able to get rid of that 3 there. This one would cancel this one, and then we'll only be left with the r there, right? So in other words, I'm saying we can say root, cube root, we can cube root both sides. Then this 3 here would get rid of that 3, and now we have something like r equals to root 3v over 4 pi and then 3 there. Then this would be our solution, right? You simply just need to understand. You simply just need to understand how to do your multiplicative inverse, how to work with your fractions, and the other one is how to convert your roots, maybe to even to your what is equivalent to as a in a form of brackets, right? So, but what are we doing? We are simply just doing what? Solving for x. It's just that they call it literal equations, but literally, no pun, it's just solving for x. Are we together? So that's pretty much it.